order to solve a problem for gravitational force, we first need to identify the variables. We are going to have planet A, this is the mass, planet B, this is the mass. The question says, what is the gravitational attraction, that would be the force, between the two planets if the distance between them is 435,500 kilometers. And we are going to use G with a normal value that we always use. The force is then going to be G mass 1 mass 2 divided by the square of the distance between them. We need to realize that this is going to be in kilometers, therefore we have to change it to meters. When I put the numbers, I have that the force is going to be 6.67 times 10 to the negative 11, multiplying the masses, 6.2 times 10 to the 18, by the other mass, 2.25 times 10 to the 20, and everything is going to be divided by the distance, which is 435, 500, because I'm changing from kilometers to meters. I multiply this times 10 to the 3. When I do this operation, I get that the force is going to be equal to the following. I'm going to show you how to put this into the calculator. We have 6.67. Instead of using times 10, I will use the exponent. And we can see this is the exponent, negative 11, multiplied by 6.2 exponent 18, multiplied by this number, 2.25 exponent 20, and I'm going to divide everything times the distance square, divided by 435, 500 exponent 3. And now I'm not going to put exponent, I'm just going to do the square equals. So this is 4.9 times 10 to the 11, and it's going to be newtons. Therefore the answer is going to be letter E for this problem. Another possibility is that we need to find the velocity or the speed of a problem. I'm going to solve problem 10. It says, what speed should a satellite of mass 2,500 kilograms at 7.5 times 10 to the 9 meters above the center of the sun of mass 1.99 times 10 to the 30 kilograms be traveling at in order to stay in orbit? So we have the sun and we have a satellite, and it's going to be traveling around the sun. We want to know what is the speed. From previous manipulation of equations, we have that the velocity is the gravitational constant multiplied by the mass of the big planet divided by the distance. In this case, the mass 1 does not affect, and this explanation is given in the previous video that talks about the manipulation. So G is going to be 6.67 times 10 to the negative 11 multiplied by the big mass. So I'm comparing 2,500 kilograms or 1.99 times 10 to the 30. This is the value that I'm going to be using because what I care about is the mass 2, the mass of the big object. So 1.99 times 10 to the 30. I'm going to divide that by the distance, 7.5 times 10 to the 9. And these are meters, so I don't have to worry about anything. I already have all the values, and the values are in such units that they fit together. When I do this operation, and I will show once more how to do the operation, I have 6.67 exponent negative 11 multiplied by 1.99 exponent 30, divide that by 7.5 exponent 9 equals, and don't forget to get the square root. The answer is 133,032. So I'm going to change this to 1.3. I move the decimal point, 1, 2, 3, 4, 5 times 10 to the 5 meters per second. And I can see that the answer is going to be letter C.